Okay, so we're going to talk today about a little bit more about lists, in particular, the mutability of lists. Okay, prior to this point in time, all of the data types we've used, including strings, ints, floats, booleans, are immutable types. Immutable simply means that something cannot be changed, okay, which seems a little strange because we know that we change our variables all the time. So what is really happening behind the scenes when we do something like count equals count plus 1? Okay, so this simple expression causes Python to do a lot of work for us. First, it retrieves the value in count. It adds the 1 to it. Then it creates a new variable, also called count, and stores this updated variable into the new memory location. The old version of count is then destroyed. Okay, to us, it looks like we've changed the variable, and that's how we think about it, and we should think about it that way. Okay, meanwhile, behind the scenes, Python has created a new variable with the same name. Lists, on the other hand, are mutable objects, okay, which means that in practical terms, when you change a list, you are actually changing it in place, is what's known, the terminology we use. Okay, so here, for example, is a very simple list. I'm going to take this list and I'm going to open up my Python 3 interpreter. Okay, there's my list. And one of the things we can do is we can use the ID function to determine the memory location of a particular object. Okay, so here's our memory location for the variable called mylist. If I do a mylist dot insert, I see that I've got a typo in my slides that I'll fix in a second. Okay, that does modify the list for me as I would expect it would. Okay, and when I do the ID, it's exactly the same. So the location of the list in memory, the address of the list, remember all variables have 4 things: a value, a type, a memory location, and a memory and the name. In this case, the name is my list. Okay, so everything here, okay, has changed. So what is the real implication of this? Well, if I do something like mylist.sort, and then look at my list, okay, we can see that it has sorted it alphabetically, which is what we expected it to do. Okay, again, the memory location has not changed. Okay, but I also have no way to go back to the original variable. Okay, notice when I do this sort, I don't have an equal sign here. So previously, we've always used, something equals, a variable name equals some expression, okay, equals being the assignment operator. Now I'm able to change a variable without using that assignment operator. Okay, normally, we don't really care about this, and it works the way we expect it. Okay, but there are certain circumstances that we have to be a little careful of. Okay, this is what a Python list looks like in memory. Okay, so there's an object header that stores the length of the list and what's known as a link or a reference to the individual list items, which are themselves scattered around main memory. You don't need to memorize this, okay, but just to give you an understanding of how lists are stored internally in the computer. Okay, so let's take a really quick look at what happens when we use the assignment operator with lists. Okay, so here I've got list 1 and list 2, and I am assigning, using that equal sign, list 1 to list 2. Normally, if I was doing this with something like an integer, I'd create a new variable, okay, and assign the value so that variable 1 and variable 2 have the same value initially, but they'd have different memory locations. So let's take a quick look at that. So here I'm going to do a variable A is 1, 2, 3, 4, 5, and going to look at the ID of A. And when I say B equals A, which I can do as an assignment, and look at the ID of B, Okay, they're actually both pointing at the same thing initially until I make a change. So if I say b equals b plus 1, and then look at b, okay, now b has been moved to a different memory location. Okay, and if I look at a and I look at b, okay, they've got different values associated with them. Okay, this is the behavior we expect. This is what we were hoping to accomplish. Okay, and it's interesting to understand. Now let's take a look at how that works with MyList. Remember, my MyList is now the sorted version of MyList. Okay, and it has also a memory location, okay, or an address. Okay, so I'm going to make a new list, and I'm going to set it equal to MyList. As we might expect, okay, when I do that, new list starts out with the same memory location as MyList. That's exactly what happened up here when I created the new variable b. Okay, it initially had the same memory location as a. But let's see what happens when I change my new list. So I'm going to append something. Oops, I might need to do that in the correct way. To my new list. 6th. Now if I check the memory address, okay, it hasn't changed. So here, new list started off at the same memory address as my list, and that hasn't changed. Okay, as compared to here, when I added one to B, that forced a change in the memory address. In real practical terms, okay, new list looks exactly as I would expect it to. I've added a new value to the end of it using the append method. Okay, so I have that value 6th at the end. Okay, but what's interesting here is that my list has also changed because both new list and my list are pointing at the exact same memory location. Any change I make to one of these will also be changed in the other. So if I say my list sub 3 equals 10th, just because, okay, when I look at my list, we'll see that change. Okay, remember that lists are indexed from 0, so 0, 1, 2, 3. We see that the 10th here has been inserted or changed. What was 2nd is now 10th. Okay, but again, when I look at new list, it also has that change reflected in it. Okay, which is probably not what we wanted or intended at this case. There's a really easy solution to this, okay, and that's using the list copy method. Okay, so if I've got, again, I'm just going to remind you of the ID for my list, okay, and I'm going to make a new list 2, okay, which is a copy of my list. So if I want to truly make a copy of it, I don't want those two things to point at the same list. I need to use the copy method. Okay, when I do that, okay, Python does whatever it needs to do behind the scenes. Okay, and notice that when I do that, new list 2, okay, has a completely different memory location as compared to my list. Okay, so if I look at the values, okay, they look exactly the same, okay, until I make a change. So now I'm going to append 7th, oops, to new list 2. Okay, when I do that, unsurprisingly, that gets added here. Okay, the difference is my list does not have that corresponding change. Now these lists are truly separate in memory, okay, and I don't have to worry about changing one causing a change to the other one. Okay. Okay, this is basically going through that example I just went through. Okay, and I'm going to do this a similar example. I'm going to do this exact same thing, but I'm going to do it in the Python tutor visualizer. Okay, so let me just grab these here. Okay, so here I'm going to start off with 2 lists. And we can see when I do that, I have my variables here, and I can see that each list is pointing to a completely different memory location, which is what I would expect. So let me come back in and edit this code. Oops, let me make it list 2 equals list 1. Okay, so if I do something as simple as this, well, maybe make it list 3 for now. Okay. Watch what happens, okay, to the memory location. Okay, so list 1 has its own memory, list 2 has its own memory, but list 3, okay, when I'm at this line of code, list 3 is simply pointing back to the memory location that list 1 had. Okay, so if I do something now like list 3 sub 4 equals, 12, I'm going to get rid of list 2 for right now. And I start walking through here. There's my list 1. I have list 2 commented out for the moment. I can see they're both pointing to the same memory location, and I can see that that memory location has now changed to the 12. So whether I do list 1 or list 3 sub 4, I'm going to get that same memory location. The other value, the other list, is simply not there at all. So how do I avoid that scenario? Again, the simple solution is to just use that copy command. Okay, so there's my list1.copy. Okay, when I go back to my visualizer, okay, there's list 1. Here's list 3. Okay, and when I make a change, only list 3 has changed now. These are completely separate memory locations, completely separate areas, and cannot, you won't have an inadvertent situation where one changes to one list may impact another list. This is almost always what we want to do, but there are times when we prefer, okay, to have that, have something be the same. Not usually with 2 different variable names, although that can happen in rare circumstances. Okay, so now we're going to talk a little bit about passing lists to functions. Okay. Because passing a variable to a function involves a assignment operation, okay, the same thing happens basically when we're copying a list to a function. By default, we do not get a copy of the original list. By default, we get a pointer to or a reference to that original list. Okay, so we're going to see this little sort list function happen in 3 different ways. And I'm going to continue to use the visualizer because I just think it's really convenient. Okay, so here's my code. Let me, I'm actually going to just copy and paste this code in here. I guess I can take all of it. Okay, so let's walk through this. I have something called myList. Okay, then I have a function called sortList. Okay, I'm passing myList to the sortList function. It gets a variable named list1. Okay, then I'm using the sort method of the list class and then returning the sorted list. Okay, that return comes into a variable called ordered. Okay, and then I print both of those. Okay, so let's see what this looks like as it executes. Okay, so the first thing is the definition. Definition doesn't really do anything, it just defines the sort function. Okay, now I'm going to start the actual code. There's my list. Okay, and we can see here when the function sortList was called, instead of creating a whole separate memory location here, okay, list1 is merely pointing back to that original memory location. Okay, we go through, we sort it. When that happens, both my list and list one have been sorted because they're pointing at the same spot in memory. Okay, it's getting ready to return. It creates a new variable called ordered, also pointing to that exact same memory location, and then it prints out each of the lists. So you can see here that even though this had a different variable name in the function and it was returned to a variable name called order, in reality, what we've done is modified the original list. Let's compare that to something that is different. Let me go edit the code. I'm going to create a, regular variable, change value, and I'm going to say a equals 5 and return a. Okay, so this is kind of the same idea. I have a variable coming into my function. I'm going to change its value to something, and then I'm going to return that back to the calling function. Okay, so let me see, a equals, or well, let's say x equals 8, y equals change value of x, and then I'll print x and print y. Okay, so let's see what happens when I do this as compared to what happens when I do it with lists. Okay, so I'm going to have a little trouble here. Okay, define the first function, define the second function. Okay, now I'm creating a new variable x, and I'm going to call my change value function. Notice right away I ended up with a copy of that value x. I don't see it pointing to the same x above. I see an actual copy of it. Okay, that's because it's not mutable. It's an immutable type. Okay, I changed the value here. Okay, a is changed. Okay, I'm getting ready to return. Okay, when I return, that y gets created here and gets copied, and now I'm just going to print out, and my x and my y do have distinct values. Okay, this is what happens when you call a function with a immutable type, which is what we've had thus far. Now again, I'm going to walk through the exact same thing. I haven't changed this code at all. Okay, so I've got my list defined. Okay, I've got now list one, instead of being a separate memory location pointing back to my list. Okay, the sort happens in place, getting ready to return, and again, I have those two things both pointing to the same memory location here. So, and then when I print them, they're the same. Okay, so that's the difference in mutable versus immutable types when I call a function. Okay, so let's figure out ways to fix that. That's probably not what I wanted with my sort list function. I'm going to get rid of these because I don't need them anymore. Okay, so there's two different ways I can fix this problem. Okay, first of all, I can make a copy of the list when I call the function. Okay, or I can make a copy of the list in the function. Okay, either one will solve the problem and leave the original list unchanged. Okay, let's see what each of those looks like. So I'm going to simply make a change here, okay, to copy my list before I pass it into the function. Okay, so there's my sort list defined, my list defined. Notice now I get that same behavior I had with immutable objects. Okay, so now I truly do have a separate copy of list one, okay, in a separate memory location. Okay, when I come in here and I do the sort, only this version of it gets changed. I'm getting ready to return. When I come back to my calling function, okay, I have two different versions of this. Okay, and when I print them out, that's reflected in the print. Okay, so we can see that the using the copy here resulted in exactly what we had hoped from the making this work like it's an immutable type. Okay, so the sort list function now truly does something and returns a completely different list. Okay, let's make one other change. I can fix this in another way here, I can say here, I'm going to do that copy function, but I'm going to do it inside the function. And I'm going to make sure that any modifications I make are on that copy. So we'll visualize that again. Again, define the function. I know this is getting tedious, okay, but bear with me for another few seconds here. Okay, now I'm going to call the function, and we'll see that originally this variable is going to point back. Okay, this is a mutable object, which means when I do a copy or an assignment, by default, I just point two things at the same memory location. Okay, when I make a copy of it, okay, now I'm in that same situation I was just a few seconds ago, where within my function, list 1 still points to the original, okay, but now list 2 is truly a separate copy of it. Okay, and then I'm going to sort it and return it. Okay, now when I do the return, ordered is pointing to that location that was previously called list 2. Okay, and when I print, okay, everything is still good. Now there is one thing you have to watch out for here, because again, if you just use the assignment operator, you can end up in a situation where you have actually 3 things pointing to the same memory. Okay, so let's walk through this one. Okay, so calling the function, okay, all good. Now I'm ready to create the variable list2. Okay, but because I forgot to use that dot copy, okay, now I actually have 1, 2, 3 different variables pointing to the same memory location. Okay, and I can refer to any of those 3, and I will always basically be referring to the same memory. Okay, so the bottom line here is remember to use that copy operator if you want a copy of the list. I'm not going to skip that. So here's our summary. Okay, lists are mutable objects. Okay, mutable objects can be changed in place. That's a strange term, but that's what we refer to it as in computing. If you truly want a copy of the list, you need to remember to use the copy method. Okay. By default, passing a list to function does not automatically create a copy. Okay, so if you truly want a copy either before you go into the function or inside the function, you again have to use that .copy method. However, when you're returning a list from a function, you should be in OK shape as long as you've set it up correctly using the copy within the function.